What if I told you that everything we thought we knew about the universe, its age, its earliest galaxies, even the laws that govern its expansion has just been shaken to its core? In just its first year, the James Webb Space Telescope didn't just take pretty pictures of distant stars. It broke physics, challenged cosmology, and revealed an invisible side of space no other telescope ever could. And now, for the first time, we are rediving deep into the most powerful images and mind-blowing discoveries that Webb unveils, some of which scientists are still struggling to explain. From galaxies that shouldn't exist to the clearest views of alien atmospheres, the Webb telescope opened a door we didn't know was there. What lies behind it may completely rewrite the story of everything. When the James Webb Space Telescope launched on December 25, 2021, aboard the Ariane 5 rocket from French Guiana, the world held its collective breath. Years of delays, engineering miracles, and a $10 billion budget had gone into humanity's most ambitious space observatory. But no one could have predicted just how quickly it would begin rewriting the cosmos. Parked at Lagrange Point 2, about 1.5 million kilometers from Earth, Webb was designed to peer into the infrared universe with a clarity and depth never before possible. And within weeks of coming online, it delivered images that stunned scientists and the public alike. Its first deep-field image, revealed by President Joe Biden himself, captured thousands of galaxies in a tiny speck of sky, each one bursting with color, motion, and stories from over 13 billion years ago. That single frame contained more information than entire missions before it. And it was just the beginning. Webb's unique infrared capabilities allowed it to see through clouds of gas and dust, unveiling stellar nurseries where stars were being born. The Carina Nebula, with its towering cosmic cliffs, came into view in breathtaking detail, revealing star formation in real time, something the Hubble could never capture. But Webb didn't just impress with beauty, began to disturb science itself. One of its earliest findings was the detection of massive galaxies that formed just 300 million years after the Big Bang. According to existing models, such galaxies simply shouldn't exist there. Too big, too old, too structured. Some scientists even began to wonder whether our entire understanding of cosmology, including dark matter and the inflationary model, needed rethinking. This was more than a camera yet, was a time machine shaking the foundations of physics. Webb then turned its mirror toward exoplanets. For the first time, scientists could examine the atmospheres of distant worlds with precision. In the atmosphere of WASP-39b, an exoplanet 700 light-years away, Webb detected carbon dioxide, a first in exoplanetary science. This confirmed that we can now chemically fingerprint planets hundreds of light-years away and possibly one day detect biosignatures. The implications for the search for alien life became significantly more real. But Webb didn't just fear it, looked near too. In our own solar system, it revealed fresh details of Jupiter and its auroras, cloud formations, and storm systems in infrared. The planet's moons, Europa in particular, were studied with a clarity that excited astrobiologists. As Europa's subsurface ocean is considered one of the top candidates for extraterrestrial life, the giant planet Neptune, long overlooked since Voyager 2, appeared in crisp rings and delicate clouds, as if reborn through Webb's eyes. Meanwhile, Saturn's rings sparkled like never before, and its tiny moon Enceladus surprised astronomers with giant plumes of water vapor that stretched for thousands of kilometers, fueling speculation about life beneath its icy crust. Even the tiny icy dwarf planet Pluto saw some attention, along with the Kuiper Belt object Eris. Webb sensitivity could detect faint heat signatures and possible organic compounds on the surfaces of these far-flung relics. But perhaps one of the most exciting moments came when Webb focused on the Stephan's Quintet 5 interacting galaxies caught in a gravitational ballet. The clarity with which it resolved these galaxies interacting, merging, and colliding offered scientists a window into how galaxies evolve, devour, and birth stars in the chaos of cosmic time. Black holes, once shrouded in mystery, became visible as Webb captured the winds and jets emitted from their cores, feeding on surrounding matter like galactic engines. These weren't simulations. Data-rich and game-changing. Another bombshell came from Webb's observations of the early universe. Galaxies with redshifts of over 13.2. This meant light had traveled more than 13.5 billion years to reach us, pushing the boundaries of how early structure could form. These galaxies were more massive, better organized, and more mature than they should be. Was the universe evolving faster than we thought? Did dark matter act differently in the past? Or was our timeline simply wrong? Theories began to shift. Some proposed modifications to dark energy models. Others considered exotic particles, or a revaluation of inflationary expansion. Webb had opened Pandora's box. Scientists weren't just excited, they were nervous. But Webb's power wasn't just in exploring mysteries, it was in resolving them too. For instance, star formation rates once poorly understood were now measured across epochs with accuracy, helping refine models of galaxy evolution. Star clusters in the Tarantula Nebula were mapped in 3 dimensions, giving astrophysicists a detailed look at how supermassive stars impact their environments. Webb also investigated quasars, massive black holes at the centers of early galaxies. These were observed with unprecedented detail, showing how their radiation affects galactic formation, winds, and chemical enrichment of surrounding matter. Webb detected silicates and hydrocarbons in places never expected, suggesting that complex chemistry began far earlier in the universe than previously imagined. One of the sleeper hits of Webb's early months was the mapping of the cosmic web, the vast structure of filaments and voids that connect galaxies across the universe. Webb's sensitivity allowed it to detect faint emissions from intergalactic gas, revealing the scaffolding of matter that defines the architecture of everything. These were not empty spaces between galaxies, but cosmic highways of gas, dark matter, and energy. In yet another surprise, Webb picked up signs of population 3 stars, hypothetical first-generation stars made purely of hydrogen and helium. While direct confirmation is still pending, their signatures may have been observed in extremely old galaxies, edging closer to the Big Bang than ever before. Such findings will help us answer one of astronomy's deepest questions. How did the first light emerge from darkness? Meanwhile, in a more immediate sense, Webb has become an essential tool for real-time cosmic events. When NASA's DART mission intentionally smashed into an asteroid, Webb observed the debris in infrared, tracking how the impact affected its motion and composition. This proves the telescope's versatility not just in deep-time observations, but in planetary defense and space traffic monitoring as well. And the surprises didn't stop there. Webb observed brown dwarfs, objects between planets and stars, with detail that allowed scientists to measure cloud bands, temperatures, and possible weather systems. In one case, a brown dwarf displayed complex atmospheric layers with possible silicate clouds, hinting at bizarre alien weather beyond imagination. All this, and Webb, is just getting started. In its first year, the telescope has published hundreds of peer-reviewed studies, each unlocking more secrets, questioning old assumptions, and inspiring new missions. It has become the foundation for the next era of space science, where infrared astronomy takes center stage and forces us to confront the limits of our models. New collaborations between NASA, ESA, CSA, and observatories around the world are being formed based on Webb's findings. Missions to study exoplanet atmospheres, dark matter behavior, and early galaxy formation are already being redefined. And as Webb continues to observe distant stars, hidden black holes, glowing nebulae, and alien skies, it carries a profound message. The universe is far stranger, older, and more alive than we ever dreamed. With every photon it captures, it's not just revealing the past, it's offering a mirror into our origins. The atoms in your body, the energy in your thoughts, all trace back to the stars and galaxies Webb now watches like a cosmic archivist. In one short year, the James Webb Space Telescope has given us more than data. It's given us awe, mystery, and an urgent curiosity about where we come from and where we're going. It has proven that even after decades of astronomy, the universe still has secrets so big, so ancient, and so beautiful that all we can do is keep looking deeper. And that's exactly what we'll do. Because with Webb, we're no longer just observing the universe, we're rediscovering it.